Hey everybody, and welcome to Sedscast. It's your host Chad Cerutti. Joining me today as co-host is Michael Messere. Michael, how are you doing?
Doing pretty well, Chad, even though it's the beginning of a busy school week for the two of us. But I'm pretty excited about the episode we're recording today and who we have on as our guest.
Yeah, it's gonna be great. Did you see the recent SN8 and like SN9 launches that happened?
Yeah, I did last week, the SN9 test flight. It's been incredible over the past year watching SpaceX and all the progress they've made um, with their spaceship.
And even like companies like Virgin Orbit have been making a bunch of progress with the
Yeah,
launch, and it's
yep, they
really
had their first
incredible.
successful one last week.
Yeah. And so joining us today as a guest is someone who does very similar things, but on a model scale. We'd like to introduce our guest, Joe Barnard, owner of BPS.space. Joe, how are you doing today?
Hey, folks, doing well. Thanks for having me on.
Yeah, really excited to have you on. I've been you on a YouTube channel for guests who might, or for our listeners. Reset. You own a YouTube channel for our listeners who might not know. Um, but yeah, so we're really excited to talk to you. So, can you just give us a little bit of an intro of like who you are, what you do, kind of that kind of stuff?
Sure, yeah. So, like you said, my name's Joe Barnard. I build a lot of model rockets. Most of them are about a meter tall. They don't go super high, but they use really advanced control systems. And so I like to focus on that aspect of model rocketry. And then everything that I learn along the way, I'm all self taught as an engineer. And so everything that I learn along the way gets put up in video format on this YouTube channel that I run. Um, and so, documenting like what works. Some of the more fun videos are what doesn't work,
Mm-hmm.
and when things sort of go a little sideways. But yeah, I've been doing this for about 5 years now, and it is working surprisingly well. So that's pretty much what I do. I build model rockets, and sometimes they work.
Yeah, it's been incredible over the past 4 or 5 years watching your progress and the story you kind of showcase on your YouTube channel about a lot of the explosions and failures, but how you're learning from there and the progress you're making and teaching yourself. And so one question I had is, you didn't start out in like as an aerospace engineer or with an aerospace background. So what kind of challenges did you encounter trying to like enter this new field of space and rocketry?
Yeah. I've told the story a bunch of times, but I have a degree from music, a degree from a music college in audio engineering, and then, um, so like I just didn't have a huge engineering background. The only thing that I had done that was close to what I do now is first robotics in high school, um, but I didn't have a lot of like technical memories from that. Most of it was just like you know remembering like how fun it was. But yeah, I mean, it's really like if you have no business getting into this stuff, obviously, it's a lot of it is really difficult. As it turns out, I mean, this sounds silly, but there are YouTube tutorials for pretty much everything. So
Mm.
a lot of my stuff ends up being on the software end. You can absolutely learn to code from YouTube tutorials, and you know, I guess like WikiHow or whatever these sites are that like teach you things. And for mechanical design or like CAD work, there's tutorials for that. There's all sorts of stuff online. You just have to sort of be willing to put in the time to learn it. And it's not always super fun to learn, but it's great to learn the skills.
Yeah. And
Yeah,
given that
sure. And I'm sure. Oh, you go.
I was going to say, given that you're an audio engineer, was there kind of like a first moment where you kind of said, I don't want to do music anymore. I have to do something space related. I have to do rockets and figure out how to land there?
Yeah. And it actually took a path away from music first to videography. So, like halfway through getting my degree at the music college I went to, I realized that thing that happens when you look at your food too closely, and you're like, oh, like you just see your food too close up, and you're like, this is kind of gross.
Mm-hmm.
That sort of happened with the music industry for me, and I was like, oh, I actually don't want to really be a part of this, and so. I sort of fell in love with doing videography and like shooting music videos and performance videos. And the thing with being at a music school is everyone needs those type of videos, so there's plenty of
Mm-hmm.
work. And then after that, I did that for a few years and ended up in the wedding industry, which leaves you with a lot of free time during the week because everyone gets married on the weekend.
Hmm.
Um, and that is like that's like a total blessing. Like that worked out way better than it should have because it means you can just spend your whole week like reading books or watching tutorials or hacking stuff together.
Yeah,
I'm
that's
sorry,
really
I
cool.
totally forgot what the question was.
No, you're good. We were just, yeah, just keep talking. You're fine. That's
Yeah.
actually really interesting though, because like just to hear that, like the way your job kind of went, like just you were interested in doing wedding photography because you were interested in like kind of the whole like video aspect of it, led to you having all this free time, and then you needing to think, oh well, what am I going to fill this kind of free time with? I have so much of it, reading books,
Yeah.
going through these tutorials, and really like allowing you to kind of launch off and start this whole like what BPS space has kind of become since then.
Mhm.
And I knew for a long time that I didn't want to do video before I stopped doing it.
Hmm.
You can't just like dive in and have it be financially viable from day
Yeah,
one. And so like half of getting into rocketry was like looking for some exit point from the job that I was in, because it started to get like not that fun for a little while.
sure.
Mhm.
Yeah.
And given that, I mean, you were building this expertise in videography before you even had the YouTube channel, and it definitely shows in the channel because even though they're, I mean, you can learn a lot and they're very engaging. They're also beautifully edited and put together. Your YouTube
Thanks.
videos. But did the YouTube channel kind of come out of like your test trials, trying to document the progress you're making to a larger audience, or did you kind of first start developing the equipment that you sell up from BPS Space, the electronics, and then from there started your YouTube channel?
Yeah, good question. So the channel came first, but not in like a primary way. So I think I set up the channel in like October 2015 or something. And it was just there as like, all right, I'll showcase major tests and stuff like that. Like I didn't care about documenting like my processes or, what I was learning. I just wanted to show like, okay, cool, I did this at this point. Sort of like a repository. And
Mhm.
then it wasn't until like a year and a half or 2 years later where things were working well enough that I was like, okay, we could sort of turn this into a business, or like I could have the project at least support itself. Excuse me, by selling these kits. And then it wasn't until after that, like I had been selling the kits for a few months and realized I kind of like it's great, but customer service is not that much fun,
Uh
um,
huh.
as it
Yes,
turns out.
yes. No, it is not.
And it's even less fun when like you're selling a really complex control system and people spend their whole lives like there are people who spend their whole lives developing like fancy control systems and getting into this. So like how do you teach someone who has no background in control systems how to fly a thrust vectored rocket that has to work on like the first try?
Hmm.
Um, but anyway, yeah, and the YouTube channel just came out of not really boredom. I just wanted to try something new, and so it didn't really take off until a few months after I had started selling those kits, and I decided, what if I, instead of just showing the stuff that was going on, what if I like pulled back the curtain a little bit and was like, here's what happened. Let's look at the data. Let's like figure out what went wrong, and if I like present like a little more formally what I was doing, and that turned out to just totally work. There's a bunch of other things that I did, but like showing my work, um, like is what made the channel take off.
Hmm. Yeah, that's really cool. It's nice when like the things that you're doing are able to kind of feed into other parts of your life like that too. I did
Yeah.
want to ask though, what does BPS space stand for?
Yeah, so this is an artifact of having no rocketry background when you name your rocketry project. It stands for
Okay.
Barnard Propulsion Systems. My last name is Barnard, and then propulsion is like when I thought of it, I was like, oh, that's a rockety term. That'll work.
Hmm.
So the best part about that is that I build every single part of the rocket except for the propulsion system. Like, I'm not a propulsion dude. I don't
Hmm.
like build rocket motors. I buy them all commercially, or I have someone else build them. And yeah, so now it's just the abbreviation. The abbreviation.
Yeah, just you should rebrand yourself to whatever Barnard everything but propulsion systems would end up being.
Yeah, yeah.
Yeah.
And so one of the most interesting aspects, other than of course launching the rocket up, is how you're able to kind of mimic what SpaceX and other private space companies are doing nowadays with landing their rocket boosters and being able to save on the money side there. And what exactly goes into And like, what kind of approach do you take to tackle that problem of trying to land a rocket?
Um, well, on a high level, I try to work within like existing things that can simplify the problem. So that's a like very vague statement, but basically that sort of goes. It's a good segue. Like in using store bought propulsion or store bought rocket motors, I can solve a lot of the problems that people, if there are a bunch of people trying to do this at this point, trying to do the propulsive landing thing, just because it's cool.
Mhm.
Um, and a lot of folks are like, they jump into it being like, I'm going to make my own hybrid or bipropellant or somehow throttleable rocket motor. I'm going to build my own, underestimating that, like, again, people spend their whole lives doing propulsion system design. Like,
Yeah.
it's not a field that you can just jump into and be good at right away. So simplifying a lot of those problems, thinking like, I'm going to try to add as few systems. I mean, Elon, I whatever disagree with him on some stuff, but like he says this one thing, like the best part is no part, and that's kind of the approach that I am taking, which is like I'm going to design around what I know will work, and add as few things onto it as possible, if that makes sense. So like I don't try and throttle the motor for landing with any like extra hardware. I just tilt the rocket over, because that'll effectively bleed off the thrust.
Sure. Hmm.
Yeah. I don't know if that totally answers the question, but the general philosophy is like I'll just try to like keep it. There's nothing inherently simple about the project, but try to keep it as simple as I can.
Well, yeah, sure, and like break it down at least into pieces that
Sure.
are simple in nature, and then they'll come together into something that's complicated, like
Yeah.
launching a model rocket. What are some what are some projects that you're working on right now?
Okay, so we have a few. One of them is Scout. That's the rocket's name, and that's the one that launches and then goes back and lands. That has been in the works. I mean, literally since the project started in 2015. It's been through like a billion iterations. Like any long term project, it goes through like different life cycles and stuff like that. But that's like the flagship. I'm trying to work on this air launch model rocket where we drop it from a model plane. I mean, like we were saying at the top of the episode with Virgin Orbit, it actually is a replica of their vehicle, the Launcher One. Um, and it turns out it's just stupid hard to connect those two, like, big control systems together and like get them
Sure.
all to play nice. And so that's, I mean, I started that project almost a year ago and I'm like still trying to figure out how to get the plane to work. But
Yeah. Do you need any permits to launch something like that? Because at that point, it seems like it
um,
could be a bit dangerous.
yeah, it depends on like weight. There's some FAA stuff. There's also I don't think there's anything for the NFPA. There are some things to like work around with that. Yeah.
Mhm.
Um, but okay, and then in terms of other projects, one of the things I realized like a month ago was that we need to like I'm going to land this thing at some point, whether by luck or otherwise, and I'm going to need a new goal. So the new goal is space, which is a lot higher and a lot harder.
Literally, yeah.
Yeah, well, it's harder in different ways too, because a lot of it is going to focus on mechanical design and like modeling and simulation.
Hmm.
I'm good at modeling and simulation, but the mechanical stuff is more difficult. Um, but yeah, I've got that. I've got a level 3 rocket, which is I'm going to try to send it to 10 kilometers this spring. And there's a couple of things in the works.
Mhm.
Cool. Yeah, and so you mentioned, oh, sorry, you mentioned earlier that you build everything but the propulsion systems.
Yeah.
So, like, how does that change then? Because you've obviously designed a couple rockets at this point from the projects you're working on. How does that change when you get to these larger rockets that are going to go up to like 10 kilometers, say, or up to the Kármán line, like 100 kilometers?
Well, the first way it changes is that your wallet hurts a lot more. So, like, for some of these motors, you're shelling out like well over $1,000 for one
Oh,
burn.
wow.
Where if you were going to cast the propellant yourself, it would be like $200. But you're paying for like the expertise and the reliability of the manufacturer, depending on who you use. But
Yeah.
like that's change number one. But there's like a surprising amount of availability, and if you work with some of these propellant manufacturers, like they design stuff for the Department of Defense, they design stuff for all scales of vehicles, whether they sell it like as a model made thing or not. And if you once you go beyond a certain level and you can like file your own waivers, you can fly like a lot of stuff. There's a decent and there are a bunch of there are a bunch of different configurations that get you to space, like between single stage and two stage, between like doing a boosted dart where the second stage is just like not even under propulsion. There's a ton of different ways to do this. Yeah, so there's options.
That's really cool. And so with regards to then even like your rocket design too, are like what are some of the changes that you're envisioning you'll need to make to your current designs for the smaller rockets? If you even have them. I know
everything, I think.
Yeah.
Like literally
like
everything.
Years out too for you. So
yeah, very little of what I fly right now scales well to going to space or going very high. So all of my airframes are made out of cardboard, like a rolled cardboard tube. That doesn't work so well if you're going really high and like Mach 3. And so, different airframe materials. You have to have a vehicle that's either passively stable on its own or way closer to it. So a lot of the rockets that I fly at the small scale use a gimbaled rocket motor. They point it in different directions, like balancing a broom, right? So it's called thrust vector control, and they stabilize, but the vehicles are naturally, like aerodynamically unstable. And so if you go really, really fast, it becomes very hard to keep a vehicle upright if it's not naturally stable. So like that's a change. The motor occupies a greater and greater percentage of the vehicle's airframe as you go higher and faster. And for the small stuff that I build, it's like, a tenth of the mass. The mass propellant fraction is like nothing. But you start to approach a mass propellant fraction of like 90%.
oh, wow. Okay.
I mean, it depends on how you build it and like what you're flying, but
sure, but like still a significant change, yeah.
Right, yeah.
A lot of this reminds me of NASA in the 50s and the 60s, like in their iteration process of going to the moon and trying to get further and higher up. And so you keep mentioning the word "we" when you're talking about BPS.space, but you mentioned that you're also the sole owner of it. And so I was wondering, like, do you have other people working on the project, or do you plan on expanding to hit that target of getting near the Kármán line in the next few years? Or would you like to keep it just on your own, like your own personal project?
Yeah, it was just me for a long time. Until last summer, I hired an intern. This guy, Parker, did a great job. But I hired an intern for like 3 months just to try it out, because I knew that, like, if I want to accomplish like larger things, you cannot do it alone. And so that was great. We're doing 1 or 2 more internships this year. And then we'll do, I think, a full-time hire at the end of the year for the business. But when I say we, like, part of it is, when I talk about the project as we, part of it is that, there are a lot of people who are like adjacently helping through, sending emails with ideas on how to fix things, or people volunteer like time on their CNC mill or something like that. And then part of it is I just hate using the term I. It feels like really braggy if I'm like, well, I did this and I did this and I did this. And like, I guess I don't know. It just feels weird. So we use a more comfortable term.
That's, definitely understandable. Part of that too, I'm sure, and I know you've talked about this a little bit in your videos, and like you even briefly mentioned it earlier, is this like imposter syndrome that kind of comes with not being an aerospace engineer by trade, but having to learn all of it yourself. How is that something that you've tried to work around and like deal with throughout the last 5-6 years that you've been doing this project?
I just like prepare a lot for stuff now. And then, I mean, I don't know. I think a lot of people have imposter syndrome no matter how many qualifications they have. So that's like a little bit of a comforting thing. I don't have like one answer for how I have fixed it, but I've started in like specifically in like the last few months or last year, really, I've started approaching my projects as if they are way higher risk than they actually are. And this is sort of in preparation for doing larger stuff. You can't just like mess around with space yacht level like rocket motors. becomes a little more dangerous. But yeah, I've started approaching my projects as if they're way more serious than they actually are. So, like, you know, legitimately trying to analyze, like, okay, what's the risk that this system fails? Or, you know, running a ton of simulations before anything flies or anything leaves the ground, doing tons of, like, you know, proper test campaigns where I write up a thing after that says, okay, cool, here's exactly how the campaign was run. Here are the results. Here's what we were expecting. I deal with it by just going a little harder on the on like trying to pretend I'm like a proper space company,
Sure.
and it kind of helps.
I'm sure, because it then makes
Yeah,
you feel more comfortable with what you're doing, because you feel like you've done all this research and preparation for the launch. That it's not
yeah.
like you're not some just random guy getting
And dude,
prepared for the launch. Yeah.
nothing looks cooler than a document about a project that has like your logo in the top right and like blank blank project log or blank blank, like, you know, XYZ proposal. Like, it looks cool.
I'm sure. Yeah, that's awesome.
Yeah.
Awesome. So, like, what's your favorite rocket to design and launch through BPS.space? Is it the Scout mission because you've invested the most time in that, or any others?
It's probably Scout, just because of the complexity and like
Mhm.
that's the original goal of the
Mhm.
project. I do like it is actually not my favorite design to work on. The CAD file is like kind of a mess. I was still trying to figure out Fusion 360 when I opened it up and like started working on it. So there's a bunch of like improperly done things in there, but I think it's probably Scout. Um, It's also funny. It's like way less of a rocket and way more of a drone or a UAV. Like, if you were to classify it, like, I guess it uses rocket motors, but it's honestly it's closer to like a quadcopter at this point.
Yeah. And so when you're
And
essentially dropping like your rocket from the quadcopter, what kind of, you mentioned a little bit earlier about kind of the thrust vector control system of kind of wobbling the rocket back and forth to land it
Mm-hmm.
properly. So what kind of like modeling goes into a process like that, or what type of electronics do you have to build to kind of get it to land properly? Because I know the goal was to initially have it land, and you've gone very close where it kind of hovers a meter or so above the ground. So what kind of
Yeah.
is the next the jump? What's the next leap that you have to make to make that happen?
The last two things I need to close, based on where I'm at right now. The last uh, landing attempt was in November, and so we launched up to like 30-ish meters. You know, not very high, but like 30 meters or so, and then came back down. I think we hovered, like you said, like about a meter above the ground, and then dropped. Um, and the last two things to close are one. So a big thing in control systems is called state estimation, and it's where you try to get the vehicle or the computer or the system to understand exactly where it is in space, right? So where am I? How fast am I moving? Where am I pointed? Um, and that lets you, you know, generate control commands so that you can arrest horizontal velocity or change your angle or whatever. Um, and that is a little hard to tune without flying and getting real sensor data back first. And it's a little hard. It's just a very complicated system, and so that needed tuning, and that's like one of the main reasons for the failure last time. So just dialing that in, making sure the rocket has a better idea of where exactly it is and how fast it's moving.
Because I
And then the
mentioned that's
second one,
I
oh, go
imagine
ahead.
it's really difficult, like that separation between the rocket trying to figure out where it is now, or like there's a slight delay between what the computer knows and where the rocket actually is. So I imagine that
Yeah.
plays a big role in trying to land it.
Well, there's a slight delay, and there's also it. How do you know which data is good, and how do you know which is bad? Like fault detection, or just, you know, tossing out data that's too noisy. Um, there's so many things that you have to dial in to
Mhm.
make sure that the control system is happy. And then the other thing that we need to fix is when the rocket touches down, the ground is always spongy. I like to land on grass
Mm.
because if it doesn't land well, it's pretty like survivable for the rocket, even if it's a higher drop. Um, people always say you should land on concrete because it won't bounce as much. And like, yes, that's right. It will also destroy the rocket if it falls on the concrete.
Yeah, it won't bounce when it tips over.
Yeah,
Right.
right. Or and it'll probably be fine if it tipped over, but like it'll scratch up the paint. It won't look nice. And I don't know. This stuff goes up on YouTube. It has to look good.
Of course.
But yeah, so fixing the landing bounce is going to be a fun week or two. And I kind of think that we can copy SpaceX a little bit and use a crush core. It's all about absorbing the energy and not letting the energy from that touchdown go back into the system, right? We want to absorb it as heat and sound and whatever else in like a crunchy zone of the rocket or something like that, so that when we touch down, we don't come back up.
Mm-hmm. Yeah, and correct me if I'm wrong, the crunch core works like it's basically a piece of metal or whatever it is.
Yeah.
That just crushes every single time, and then you need to replace it in between launches because it's just like a piece of metal or that just crunches down, absorbs all that energy, and leads to a softer landing, right?
And so, yeah, they use it's an aluminum honeycomb that gets like crunched.
Yeah.
It's literally called a crush core, yeah. But I like kind of think we can do it with like tin foil or aluminum foil. I mean, it's a great. I think it'll make a great video if it works.
Yeah, that'd be great. And what kind of planning goes into all these launches? Because I know one thing I've noticed with your channels, you don't record them live, and I imagine there's a lot of nerves and a lot of preparation that goes into it. So I was hoping you could kind of describe kind of the days leading up to and all the preparation that you have to put into it.
So I don't like record the talking segments live because I can't do the data. I do stream the launches for how the project is supported. This isn't like a formal plug, but I stream it for the people who like financially support the project on Patreon. But oh my gosh, I forgot the question. Can we start again?
Yeah, go for it.
So just what kind of preparation goes into your launches? Right.
Okay. So preparation wise, everything is planned out like the day before. I get a little religious with it, or like a little strict with it. So I've got this whiteboard that by my desk where I write out the timeline of the whole day and like exactly what time things should happen. And so you build in like 30 minutes at the launch site for things to go wrong because you never show up and everything is ready to go. You always show up and something's like, oh my God, why is this not working? And so then you build in, you can use Google Maps to like try to find the traffic that day or the time that you expect to drive. And so for me, that's like an hour-long drive. If there's traffic along the way, you add 20 minutes to that. Then I'm planning out a lot of the power budgets on the vehicles and the cameras are a little tight, right? And so if things are running for a long time, you just want them to be fully charged when you get there. So a lot of the early day is finalizing the charge on the camera and making sure it's totally topped off. Then loading pyrotechnic charges, that stuff you don't really want to do like too far beforehand. You kind of want to the risk is just naturally heightened once those charges are in there and connected. So that happens on launch day. There's a ton of tiny things, but it basically gets blocked out as like, okay, at 11:30 a.m., in order to meet the deadline of launching by 6 p.m., we have to be doing this task. So it's really tightly planned out. And then the other thing too is that I know if I'm going to make the launch date or the launch time early in the morning, if like something takes 2 hours and it was supposed to take 20 minutes, I already know I'm not going to be able to safely get to launch. And it's going to be better if I push it off to the next day instead of trying to rush the rest of these processes. I don't know the plural.
Oh, yeah,
whatever the word is.
Yeah, that makes a lot of sense, the planning process.
Mm-hmm.
And that's also, sorry to keep talking on this question, but that's also like, you don't really have to do that, but that's part of the thing I mentioned earlier, where like taking the project a little more seriously than it actually is, so that when I get to larger things, I'm like already in that mindset of let's block all of the time out and be really precise about it.
Sure. Yeah, it won't be I'm sure there'll be additional safety steps that you'll take, but like the whole thing won't be that different from what you've already been doing anyways. Yeah.
Right. Yeah.
And you've had the chance to work out the kinks too, I'm sure, from the whole process when there was much lower risk than when you will have this like orbital class rocket or model rocket like in your possession.
Yeah. And like, I don't know if either of you like launched like, high power rockets or model rockets.
I launched when I was in like elementary school. I put that little like Alka-Seltzer and like vinegar tablet in a little film canister, and it shot 10 feet above the ground. That's what I've done.
Yeah,
Those are
Is that?
fun. I think you can
Yeah,
launch them from your hand too. I
yeah,
don't know
you
if you're
definitely
supposed to, but
I
my
took
teacher
the
wanted us to be safe. We had the range requirements for 10
yeah,
feet away.
yeah.
Yeah.
yeah, I was a Cub Scout, so like same time elementary school, I
Oh,
launched a few
cool.
rockets. One of my friends, I remember he like his dad made this model. Um, what's the outside bathroom called? A outhouse,
Porta potty.
porta potty, and he launched it with like it was like a model rocket size.
That's
That's awesome.
amazing. Um, anyway, the point that I was trying to make is at least I mean I think it's different when you're in elementary school or like that level. But launch day is crazy stressful, and you can't trust your brain when it's under a lot of stress. So like checklists and I mean basically just checklists to make sure that you are hitting the milestones you need to hit. And like early on, before I started doing lots of checklists, there like may or may not have been a an event where I launched the rocket. I like sent the launch command to the launch pad. It fired the motor, and I had not actually turned the rocket on, like powered it on. Which like don't do that. So checklists.
Yeah, that
Yeah,
makes sense. That's a learning moment for sure.
yeah,
So what
yeah.
are some of the scariest moments? You mentioned that one. But any other like really scary moments or big challenges you came across with rocketry?
I had a scare this past summer where so the flight computers are getting a little pretty complicated, right? They're controlling a lot of the pyrotechnic charges on board, especially with Scout. Like it has the ability to, whenever it wants, fire that landing motor. You don't really want to be close to it when it is going to do that. Um, but so like state transitions, like moving through different states in the flight software, is really important to have a like total certainty in. And I had a scare this summer when I was like building the code base for this new flight computer that I've been using, where the rocket like anomalously moved into the wrong state and then fired the parachutes on the pad. And it's a tiny charge, right? It's like a gram of black powder at most. It just pops the nose cone off, but I was right next to it, and I don't know. That was definitely one of the scarier moments. I mean, I didn't. It's just over in like a half a second, but you really don't want to do that.
Yeah.
And you know, it just brought the issue of like, okay, I need to be more careful with how I'm setting up my flight software. I've had like one or two of those things along the way. I feel pretty lucky to not have had things go worse, especially with some of the early rockets where I it was a lot more haphazard. At least there were opportunities for things to go wrong that somehow like didn't.
Mhm. And then I know a lot of school groups that work with rockets. They'll either launch them on campus in grassy areas that it seems like you seem to be launching them at, or sometimes they'll make trips out west to like the LA
Yeah,
area where there's a lot of deserts. And so is that something as you move forward you'll have to go out to a desert region to launch these bigger rockets?
yeah. Right now, the field that I launch in is this like nice little grassy model airplane field. This seems to be a thing that's totally like regional to the south, but we've got like a ton of model airplane fields with like little RC airstrips all over Nashville, Tennessee. But
Wait, is that not normal? Like I grew up in Florida, like we have
so
those like littered around too.
okay, so that confirms like you grew up in the south
Yeah,
and
is
it's there, right? I grew
that's
up in
not normal?
Boston, Massachusetts, and there's like nothing like that around there. I looked around the LA area and I didn't find anything like that.
Hmm.
Maybe it is more normal than I think, and I'm just bad at looking. But
Well, I mean, Michael,
to
you grew up in New
I'm
York.
from New
Like,
York, so yeah, we have
oh
little
yeah,
grassy areas about. Mhm.
okay.
do you have any RC airstrips there?
No.
There
Hmm.
it is. It's
Hey.
only in the south. Okay. Anyway, the point is that yeah, I launch in a little grassy area right now, but that doesn't scale up super well. And it just my family ended up moving out to the LA area a little while ago, and so between my family being there, there's like way more space because, like you said, there's a ton of desert out there. There are a couple of places that have standing waivers for rockets and are like set up to do experimental rocketry stuff.
Mhm.
So that makes sense. And then, of course, there's it's a huge aerospace hub. So if something ever went wrong or I had to get a job somewhere else, that's pretty much the place to be for me. So I'm moving out there later this year, I think.
Oh, okay, great.
Oh, nice.
Yeah.
Congratulations in advance for that. Yeah.
Thanks.
Yeah. And I know in some of your videos you mentioned that what kind of inspired you first to start this BPS.space channel and kind of entering the model rocketry field is you saw those early SpaceX tests, the hopper tests, where it would go up the Falcon 9 and land itself. And you also mentioned that you wanted to kind of show SpaceX what you could do without necessarily going back to school for a few years for an aerospace degree. And I was wondering, is that still in the back of your mind, like getting hired by not necessarily SpaceX, but a private company in the space industry? Or do you kind of do you ever see yourself in that position for working for someone else?
Yeah. I think that's a reality that, like, I don't know, it still feels very lucky that what I'm doing continues to work out. And like, maybe it will continue for the rest of my life. It probably won't. I feel like at some point I'm going to make a few bad calls and that's going to like, that's going to be curtains for BPS, but we'll see. And if that happens, I think I'd be totally fine working for someone else. I think, I would love to work at a tiny company. I mean, SpaceX is awesome. And they do, they tackle crazy hard problems. They push really hard. But at a tiny company, I kind of thrive a little bit on the chaos of being in a tiny environment where like you have a little more responsibility than you probably should. I really love that. And so I'd want to be somewhere where, the challenges are really hard and you have just a little more on your plate than you probably should.
Yeah, and I think what's great about that is you're not necessarily an expert in one thing, but you're kind of somewhat of an expert in a bunch of different fields. So you can have your hands everywhere, and you can have kind of control over how the process goes on.
Yeah, exactly.
That's really cool.
I also would probably do a lot better with like more stability in my life. Like most of my days are just chaos. Like I have no idea how to structure my own day. And so it would probably be good for me at some point to work a 9-to-5 job.
I guess if it's working for you now, though, I mean, why stop that, right?
It's working better than it has in the past, and I'm getting better at it, but we'll see.
Yeah. Well, so one of the things we love to do on Sedscast is we are a student-run and student-focused podcast. So we love to ask our guests if they have any advice for students. So then specifically for you, I wanted to ask if you have any advice to some students that are getting into model rocketry and they're novices. What should they look out for and what should they try to prepare to do?
Let's see. I guess it really depends on the rocket project, but I would say try to spend time solving the right problems. I'm just pulling from the internet. These aren't specifically students, but I've seen a couple of people start projects that are similar to mine, and they're solving the wrong problems. You get to define what the right problems are. So if you want to build a super fancy launch pad and spend no time on developing the rocket, and that's your goal, that's awesome. But that also seems like if the goal is to build a rocket, spend the time on the rocket.
Sure.
So I've definitely done that on projects before where I spend way too much time designing this fancy bracket or fancy mount or whatever, ignoring that I actually have a lot of really hard analysis to do, and I'd rather spend it making chamfers on this nice part.
Sure. Yeah.
But I wish I had better advice or more clear advice, but I feel like for me it would be try to figure out what the right problems are to solve.
I think that the presence of your whole channel is your advice because, I think people that don't necessarily have a background in aerospace engineering or a technical degree look at someone like you and they say, well, if Joe Barnard can do it, I can do it. And so I think there's a lot of inspiration to draw from your story that you tell through your YouTube channel.
Thanks. Yeah, that's absolutely true. If your boy can do it, literally anyone can. I don't know. There's a lot of luck to having it work this well. I worked pretty hard, but I also got really lucky. But I don't know. You can teach yourself anything. That's another great thing to take away. You can teach yourself pretty much anything. It's hard to know where to look on the internet to learn things sometimes. but if you spend enough time, you can really, like, there are a lot of people willing to help, and you can learn about anything.
Mm-hmm. Awesome.
Yeah.
And for those that are listening that maybe aren't familiar with your YouTube channel, your projects, where can they follow you on the internet, or where can they support you?
Sure. So the YouTube channel is just called BPS.space. If you search that, it'll definitely come up. I'm on Twitter a lot. It probably shouldn't be, but it's at Joe Barnard on Twitter, just my name. The project is supported through Patreon and like merch sales for the business, so we sell shirts and stuff like that. But yeah, I mean, frankly, just anyone following along with the project like supports plenty. So yeah, just check out the YouTube channel, and I guess Twitter. I don't know. Half of the stuff I tweet is like really dumb. So
yeah, we're on Twitter a lot too, so we'll make sure we're out there retweeting you and following along. We'll give critiques on everything that you're doing too. Don't worry. Yeah.
Sure.
It was great having you on today, Joe. Thank you so much for your time.
Thank you so much.
Yeah, thanks for being able
to talk to you.
Yeah.
All right. And with that, thank you everyone for listening. We appreciate your time and have a good day.